Alright, so we are going to review exponent rules and simplifying polynomials. So to start out, let's look at this first one, x squared times x cubed. So x squared means, if when in doubt, you write it out. So x squared is actually x times x, there's two of them, and x cubed is x times x times x. And so when we multiply everything together, we have 1, 2, 3, 4, 5 x's. So x to the fifth would have been the answer. Now, if you look back at the numbers on these exponents, well, 2 plus 3 equals 5. So when we multiply, we're actually adding our exponents together. That's our rule. So let me write that down. So if we have x to the a times x to the b, then our answer is x raised to the a plus b. You add exponents. Okay, let's look at the next one. X squared raised to the third power. So what this means is we would write down x squared 3 times. And so how many x's would we have? Well, x squared is x times another 2 x's times another 2 x's, and so together we have 2, 4, 6. So our answer would be x raised to the 6th power. Now if you go back and you look at these numbers, these exponents, how could we have gotten x to the 6th power? Well, look, 2 and the 3. 2 times 3 is 6. So our rule is, if we have x raised to the a power and we raise it again, then our answer is a times b. In words, we would say, when you raise a power to a power, then you multiply exponents. Okay, let's look at the next one. Again, when in doubt, you always write it out. You do not have to use these rules. If you write it out, it will work. That's the meaning. So x squared is x times x over x cubed. So we would have x times x times x. And if you think about anything divided by itself is 1. So x divided by x is 1. X divided by x is 1. So we are left with 1 over x. Here's the rule. Look at our numbers. Look at our exponents, a 2 and a 3. How can we get an x on the bottom? Well, 2 minus 3, right, is 1. So x to the first power. And the 3 is the heavier one. It's the bigger one. Cubed is bigger. 3 is bigger than 2. So our answer is going to go on the bottom. It's heavier on the bottom. So here's our rule. When you divide, then you subtract exponents. Okay, let's look at the next one. X raised to the negative 4th power. What this means is a negative exponent is actually meaning that it's actually a fraction. So we're going to hit the bottom to change it over. And we can talk more about this in class with some numbers. All right, so our rule for negative exponents change positions within the fraction. And what I mean by that is that let's say we had one that was like 1 over x to the negative 2nd power. So now I have a negative exponent in the bottom, so I would change position. So I would now put this on the top. Okay. All right. Let's look at this one here. Last one. Now we've got two numbers inside parentheses raising to a power, very similar to this one. So this would say that we would write 3x 4 times being multiplied. So 3 times 3 times 3 times 3. So that's 9, 27. 81, sorry. 81, 81, x to the 4th. So what's the rule? Well, if we go back and we look at these exponents here, the 4, the 1, this 3 technically has a degree of 1. Here's what the rule says. Okay, if you had then this would be a to the b times x to the b. That exponent gets distributed to both things. Okay. All right, so we're going to use our exponent rules to help us simplify polynomials. Hopefully all of that was a review to begin with. All right, so examples. If we could add polynomials together here, I have a binomial plus another binomial. We're going to combine like terms. So 2a and 8a are alike because they have the same variable and the variable has the same exponent. So this would be 10a. And then we have 3b plus a negative 5b. So that would be minus 2b. Let's look at the subtraction one. This is saying a negative 1 out here. I'm going to go ahead and distribute this negative 1 through. We've had some trouble in the past with that negative subtraction. So I have negative 1 times 4x squared, so minus 4x squared. Negative 1 times 3, negative 1 times negative 5. And then we're going to combine like terms. The variable has to be the same and the exponent has to be the same to be alike. And then we have negative 4x and a negative 3x. Negative 7x. And then we have our constants. So 3 plus 5 is 8. This one is distributed because we have a multiplication here. So we're going to distribute the 2x through, so we get 6xy plus 18x. These are not alike because the variables are not exactly the same. All right, let's take a look. We're going to skip this one. Let's go down to this one here. We're going to distribute. And yes, that all gets distributed together. So 2 times 5 is 10. P squared times P is P cubed, because when we multiply, we add our exponents that we just saw on the previous screen. Q times Q is Q squared. Then we're going to take each one and multiply it to this part. So 2 times negative 3. P squared times P cubed is P fifth. When we multiply, we're adding exponents. Q times Q squared. Q raised to the 3rd power. And we want to look and see if we have any like terms, just to be on the safe side. In order for it to be alike, our variables must be the same and our exponent. And even though we have a P here and a P here, they are not alike because this is a 5 and this is a 3. And the Q's, same scenario, so we're good. All right, let's do another one. One more. Let's come down here, this last one. All right, so here we've got a binomial times a trinomial. So we're going to take the x and we're going to multiply it to each one of these. So we have x times x squared, x cubed, x times 4x, 4x squared, x times negative 5. And then we're going to do the negative 2 to everything. So negative 2 times x squared. Negative 2 times 4x. It's negative 8x. Now you'll notice that I'm kind of lining these things up with their like terms. I'm doing that because otherwise I'm going to have a very long string of numbers, and it may be a little bit more difficult to find what things are alike. So that's why I'm kind of lining them up as I go. Negative 2 times negative 5 is plus 10. And now I'm going to combine like terms, kind of like add them together. So we would get x cubed, these are alike, minus 13x plus 10. All right, well, I will see you in class, and we will do some practice on this. I also want to remind you, do not forget to do your Google form. That's how you're going to get your credit for your homework tonight. I hope that you took some good notes so that you can refer back to in class as you go to practice. All right, see you later.